TWA Flight 800, 1996. A routine Boeing 747 flight turned catastrophic just 12 minutes after takeoff from New York's JFK Airport. TWA Flight 800 exploded midair, killing all 230 people on board. The aircraft was bound for Paris when a spark inside the center fuel tank ignited fumes, causing a massive explosion that tore the jet apart. Investigators from the NTSB ruled out terrorism and determined that faulty wiring near the fuel gauge system was the cause. The tragedy led Boeing to redesign electrical systems and fuel tank protections to prevent static discharge or sparking inside fuel tanks on future models. Pan Am Flight 759, 1982. Pan Am Flight 759, a Boeing 727-200, crashed shortly after takeoff from New Orleans International Airport, killing all 145 people on board and 8 people on the ground. The aircraft lifted off into a powerful microburst, a sudden downward rush of wind produced by a thunderstorm. The downdraft caused an abrupt loss of lift, pushing the jet back toward the ground. Despite the crew's efforts to climb, the aircraft struck trees and homes just beyond the runway. The NTSB determined that the weather phenomenon, combined with insufficient detection technology and unclear pilot guidance on microbursts, caused the crash. This tragedy led to the development of wind shear detection systems, improved radar technology, and mandatory training for pilots on recognizing and escaping microbursts during takeoff and landing. Air Florida Flight 90, 1982. Air Florida Flight 90, a Boeing 737-200, crashed into Washington, D.C.'s 14th Street Bridge just after takeoff from National Airport, killing 74 of the 79 people on board and 4 motorists on the bridge. The aircraft failed to gain altitude due to a combination of ice accumulation and pilot error. During the severe winter storm, the crew did not properly activate the engine anti-ice systems and attempted takeoff with ice on the wings, which disrupted airflow and reduced lift. Additionally, they used thrust readings that were too low because of iced-over engine sensors. The plane struck the bridge and plunged into the Potomac River. The NTSB cited inadequate desing, poor cockpit coordination, and lack of winter weather training as primary causes. This disaster triggered sweeping changes in desing procedures, crew resource management, and pilot training for cold weather operations. United Airlines Flight 553, 1972. United Flight 553, a Boeing 737-200, was on approach to Chicago Midway Airport when it crashed into a residential neighborhood, killing 43 of the 61 people on board and 2 people on the ground. The aircraft was descending through low clouds when the crew attempted a go-around due to a high approach speed. During the maneuver, the pilots inadvertently allowed the airspeed to drop below stall speed. The jet entered an aerodynamic stall, meaning the wings lost lift, and plummeted into houses near the airport. The NTSB determined pilot error and poor crew coordination were the main causes. Boeing later updated stall warning systems and refined training on go-around procedures to prevent similar accidents. Delta Airlines Flight 11041, 1988. Delta Flight 11041, a Boeing 727, crashed during takeoff from Dallas-Fort Worth International Airport, killing 14 of the 108 people on board. The aircraft failed to gain altitude and slammed into the ground beyond the runway, bursting into flames. Investigators found that the flight crew had not extended the flaps and slats, movable surfaces on the wings that provide lift during takeoff. A cockpit voice recorder revealed the pilots were engaged in non-essential conversation instead of performing proper pre-flight checks. The takeoff warning system should have alerted them, but it malfunctioned due to electrical issues. The NTSB cited both crew distraction and system failure, prompting stricter cockpit discipline rules and maintenance checks on warning systems across Boeing fleets. United Airlines Flight 811, 1989. United Flight 811, a Boeing 747-122, suffered an explosive decompression shortly after departing Honolulu, Hawaii, en route to Auckland, New Zealand. As the aircraft climbed through 22,000 feet, the forward cargo door blew open due to a faulty latching mechanism. The sudden pressure change tore a large section of the fuselage away, ejecting 9 passengers from the cabin to their deaths. Despite severe structural damage, the pilots managed to return safely to Honolulu. The NTSB later found that electrical faults caused the cargo door to open mid-flight. Boeing subsequently redesigned 7047 cargo door locks and reinforced fuselage structures, leading to major improvements in pressure door safety standards. Alaska Airlines Flight 214, 2013. A Boeing 777 attempting to land at San Francisco International Airport crashed when it struck a seawall just short of the runway. The impact ripped off the tail and ignited a fire that destroyed the aircraft. Out of 307 people on board, 3 passengers were killed and 187 injured. The NTSB found that the pilots mismanaged their final approach, relying too heavily on automated systems and failing to notice their airspeed had dropped dangerously low. The auto throttle was in a mode that didn't maintain speed automatically. Boeing's automation design, while technically correct, was criticized for being confusing under manual flight conditions. Southwest Airlines Flight 1248, 2005. Southwest Flight 1248, a Boeing 737-700, overran the runway while landing at Chicago Midway Airport during a snowstorm. The plane slid off the icy runway, crossed a road, and struck a vehicle, killing a 6-year-old child in the car and injuring several on board. Investigators found that the pilots had landed at a higher than recommended speed for the conditions, and that braking effectiveness was reduced by snow and ice accumulation. The incident exposed vulnerabilities in runway safety areas at older airports. Boeing and the FAA reviewed landing performance calculations, and airlines implemented stricter landing protocols under adverse weather conditions, emphasizing runway friction assessment and stabilized approach requirements. Southwest Airlines Flight 1380, 2018. A Boeing 737 suffered a catastrophic engine failure during climb-out from New York's LaGuardia Airport. One of the engine's fan blades broke off due to metal fatigue, causing shrapnel to puncture the fuselage and shatter a window. A passenger was partially sucked out and later died. The first U.S. airline passenger fatality in nearly a decade. The pilots conducted an emergency descent and safely landed in Philadelphia. Investigators traced the failure to insufficient inspection protocols on engine fan blades. Boeing and CFM, the engine manufacturer, implemented mandatory ultrasonic inspections, and airlines revised their maintenance schedules to detect microscopic cracks before they caused failures. Alaska Airlines Flight 1282, 2024. 6 minutes after takeoff on January 5, 2024, from Portland International Airport, Oregon, to Ontario, California, the Alaska Airlines Boeing 7379 MAX operating Flight 1282 experienced an in-flight separation of its left mid-exit door plug. A panel about 29 x 59 inches blew off at approximately 14,830 ft, causing rapid decompression of the cabin. Objects were sucked out, oxygen masks deployed, and 1 flight attendant plus 7 passengers sustained minor injuries. All 177 people on board survived. The subsequent investigation by the National Transportation Safety Board, NTSB, determined the root cause was systemic manufacturing and oversight failures at Boeing, where 4 critical bolts securing the plug had been removed during factory rework and never reinstalled. United Airlines Flight 328, 2021. United Flight 328, a Boeing 787-200, experienced a high-profile engine failure shortly after departing Denver International Airport. The aircraft's right engine suffered a fan blade fracture due to metal fatigue, sending debris outward and causing a fire in the engine cowling. The pilots immediately shut down the affected engine and returned safely to Denver. No injuries occurred, but the incident led to significant flight disruptions and prompted the FAA to issue an emergency airworthiness directive. Boeing and engine manufacturer Pratt & Whitney were required to perform ultrasonic inspections on similar engines to detect cracks early. This event highlighted ongoing concerns about engine component longevity and inspection rigor in modern jets. Throughout aviation history, Boeing aircraft have faced disasters that reveal just how critical engineering and safety measures are. But similar accidents have occurred around the world under even more extreme conditions. To explore these international tragedies, subscribe and watch our next video, Worst Boeing Accident Around the World.